Hello everyone. Welcome to another webinar by Hira Waldman Academy. As you know, today's topic is seismic restraint system of non-structural components. Beside our pandemic, we have another risk of disaster, which is earthquake. So we need to discuss and focus on these subjects to save our infrastructure. This webinar, we have discussion about all of this system which is related with the MEP system to avoid any seismic forces or seismic to control from earthquake. And this all attendees, I would like to inform you all, if you have, we have this discussion for 1 hour 45 minutes for this presentation and 15 minutes for our Q&A session. So during this webinar, if someone having any questions, they can just use this raise on hand option by raising the question, and then all the questions shall be answered after this presentation. And all attendees will get their certificate of participation from Hira Waldman Academy, who has joined this webinar. So let's start this very interesting session, which is related with this disasters, to avoid from disasters. First of all, my introduction. My name is Haris Kareem, and I'm serving Hira Waldman as a product manager for seismic and vibration control products. I have more than 6 years of experience serving construction industries, with 4 years experience with leading seismic technical departments and seismic product as a product manager, and I'm specialized based on my experience in seismic and vibration control system. My educational background is mechanical engineering. So as I told you, this session we will have 45 minutes for this presentation and 15 minutes for Q&A. Then we can answer all of your questions. And if we miss out any answer, then you can then we will approach you and you can coordinate, contact with us directly by Hira Waldman Academy email address. So here we have some webinar agenda by having this content to discuss about some topics. Initially, we'll discuss who we are, what we are doing, how we are serving this market in the construction industries. Then the main topic is importance of considering the seismic activities, as our main agenda of this presentation is to discuss about the seismic activities. Then how does this, as we are dealing with mainly with MEP system, so we need to know how does this seismic forces affect our MEP system. Then we have solutions by naming it seismic restraint system, to how these forces which we are calculating, and then provide some solution to control those forces. We have our product range and we have different solutions for seismic restraint system. And then we have design approach, design methodology, where we will discuss about how to create any design or how to make design to to mitigate this risk. And then we have some application examples based on that design methodology. So if in general, if someone wants to know how to do this design or what approach should be used to design MEP system, so this will be helpful for all of us. Let's start with who we are. Let me play first this video to introduce Hira Waldman Academy, and then we'll continue the rest of the things. Yeah. presentation. So this Hira Wallavan, as an introduction, is a joint venture between Hira Industries and Wallavan Group since 2015. As you know, Hira Industries is working or serving this construction industry since 1980, and we have sales companies, manufacturing units in IMEA, Asia, and USA, and having more than 11,000 employees with 20 different nationalities. As a Wallavan Group is originated from metalwork company J1 Wallavan BV 1942, production and sales companies more than 15 countries in Europe, Asia, and USA, over 1,000 employees, more than 60 patents and counting. At a glance for this manufacturing plants in UAE and India, we have sales companies in Africa, Middle East, India, and Asia. UAE, we are UAE-based manufacturer and supplier of complete fixing system solution from pipe supports to vibration control. When we talk about quality prospect, we are ISO certified company, ROL specified MFSS member, and along with some approvals like approvals for on our products, which is FM, UL, VDS, ET, and ROL. As we have certified installation system, which includes pipe clamps, channels, rooftop supports, vibration isolator, and seismic restraint system, along with the mechanical and chemical heavy duty anchors. We have technical support services, and how do we help you, we support you by doing our services like seismic design. If we are dealing with seismic, any kind of seismic project, then we are doing seismic designs. We are doing tailored solutions for rooftop supports. We have fully capacity for anchor designs and supply of anchors, and then field testing after the installation. We have decades of experience on all type of projects, especially landmarks, and we have covered almost all type of projects. When we talk about the construction, then landmark buildings, transportation networks, high-rise buildings, along with iconic development like Expo. Our core values are think smart, fair play, be transparent, open communication, be accountable, and at the end, challenge yourself. Let's start with our another the second topic, which is our main topic for seismic, considering the seismic activity. In introduction for seismic, for the earthquakes, for any seismic event or forces, we need to understand the concept of this earthquake, and we have to gather some data based on this, which is totally we have to gather those data where we can have easily some figures for the earthquakes happening in the around the globe. And these earthquakes are it's occur every day, and it could be incredibly destructive. Since last 6 months, we have more than 1,000 events with magnitude of 5.0 magnitude and higher were registered, with several events above 7.0 magnitude. As we talk about the earthquake, then economic impact is very huge, and these losses peaked in 2011 after this Tohoku disaster, which was around $365 billion. Events occur all over the world, including in Middle East. And then we have seismic events in this region, as we are living in the beside the most active region of earthquake, and where we have different complex interaction between the major tectonic plates and tectonic block, where we have 700 events recorded in last 365 days above 5.0 magnitude. The seismic map is the main thing. Is seismic map is constantly changing. Even regions not prone to natural events need to consider artificial seismic activity caused by resource exploration. But to cover this or to save from this, every project or wherever it is required, seismic design is must. When we talk about specifically for the earthquake, it's a kind of shaking mechanism of earth, and it has two main kind of points where we have epicenter and hypocenters. Hypocenter is basically the origin where this all forces generated beneath the earth surface, and the epicenter is a vertical projection from the origin to the surface of the earth. The intensity of earthquake can be measured by different parameters, main three parameters like intensity, Mercalli scale, and then we have magnitude Richter scale, which media for media purposes, and at the end we have peak ground acceleration. While we are doing any kind of assessment, is helpful for us to measure any kind of seismic forces in terms of gravitational force. Here we have this Middle Eastern earthquake zone where we can see it's based, this data is based on last 50 years, 100 years information. And as we are close to 0.5 G, G is gravitational force, and we are close to half of this value in this region. Then we have the PGA peak ground. As I told you, we have another parameters which we use to assess the seismic forces, which is peak ground acceleration, and it's in terms of meter per second square. So we have another parameters used to calculate for any seismic forces. Seismic designs are very important for its regardless of the structures, and this all seismic events, they don't like it's totally regardless of the seismicity. And we have, as we have fire rescue system, medical facilities, stadium arenas, power plants, residential buildings, these all are categorized based on nature of occupancy according to IBC. As you can see on the left side of your screen, this all building categories from low hazard to high hazard and low risk to high risk, which is categorized under 4 categories. When we talk about importance, as we are mainly concerned about the MEP seismic MEP to control or to save the MEP system, so we need to understand how this the contribution in terms of investment we have for this MEP support system. As you can see, residential, commercial, hotel and hospitals, majority of the investments is involved in MEP system after the structure. And this out of this MEP system, we have 49% or 49% and 29% respectively for HVAC and electrical installation. And in terms of when you talk about AED per square meter, we have different figures, which is based on different installation. You can see BWIC, protective, security, and then electrical and HVAC. HVAC is leading the contribution in this construction industry in terms of investment. Then we talk about as we discuss about the seismic activities, now we need to discuss how does these forces, because of this earthquake, how does these forces affect the MEP system. Whenever we have earthquake, if we are talking about mainly with the MEP system, so we need to check or we need to consider like how does MEP system installed. We have different types like ceiling suspended, floor mounted, wall mounted. So there are different impacts based on distribution services or based on equipments because of the earthquake. When we talk about the ceiling suspended services, the more risk of the collision at different because of the earthquake movement, all services will move in at different rates, and there could be the risk to collision between these services, and then after that collision there could be the leakage or there could be the like total destruction of the any suspended service. When we talk about floor mounted equipments, we have the risk of overturning of the equipment because of the earthquake motion, because of the earthquake forces, because of seismic forces. And then we have this, because of this twisting, because of this motion, fittings could be break and couplings could come out. Then we have some measures to control these seismic forces on MEP components. As if we are dealing with ceiling suspended distribution services, then we need to do the bracing. If you are having floor mounted equipments or floor mounted system, that could be controlled by giving snubbing mechanism, snubbing devices. If we have anchoring is important for all cases, because whether you have bracing, whether you have snubbing, eventually your equipment shall be fixed to the structure by certified seismic anchors. Then flexibility, it's a part of design or parts of before seismic, it's pre-seismic assessment. Then clearance, each system, because you have bracing, in case of bracing, you must need some clearance between the services. Then load path engineering design, because might be products will be more simple to install, but calculation or engineering design is a complicated or very crucial part. Then products which are using for this application must be tested. We don't recommend to use any kind of product which is not tested for seismic. So better to proceed with the tested products for any kind of application related with seismic. Then after all the installation, we have inspections to make sure how this installation done. Is it as per the recommendation or as per the professional engineer, as per the design engineer recommendations. So inspection is must for any kind of seismic installation. Here we have some categories where we can use bracing, where we can use snubbing. As I told you, for sealing suspended services like pipe, conduits, ducts, bus ducts, cable trays, ventilation units, suspended equipments, all must need to be braced by having flexible supports or having rigid support based on the depends on the requirement. Then we have snubbing, anchoring. Snubbing, it's a mix, snubbing and anchoring. If you have equipments where you have risk for the overturning of the equipment because of the seismic force, then snubbing could be snubbing devices shall be used to control that uplift force after doing this load calculations or design calculations. And anchoring is must for any kind of attachment. Is if it is not related with the snubbing, if it is direct equipment is directly fixing to this wall, it doesn't have any kind of device which related with vibration isolator or related with the snubbers, then it anchoring must need to be checked if there is any seismic requirement. Then how does these affects to the MEP system? After that, we have how to control these all effects, how to what systems, what solutions we could do to avoid these forces or to avoid this destruction. Then we have when we talk about the bracing, we have two types of bracing, and there are two types of bracing. One is rigid bracing system, other one is cable bracing system, which gonna be next slide. When we talk about rigid bracing system, it has own benefits and own limitations. And then we have flexible bracing system. Flexible bracing system, it's like basically to use for like to control the motion the same as rigid, but it has this flexible system shall be used to control from the both side, as it is only required, as it is only having function for the tension forces. And it has its own benefits, and it can be linked directly to the pipes or clamps. It depends on the application, and as each cable is required to support full seismic loads and two lengths should be used, the system is extra secure. To make the system extra secure, both the cables should be applied from the both side of the pipe with the same angles. Then we have rigid versus cable bracing system. In rigid, we have compression and tension bracing, and in cable bracing, we have only tension bracing. There are some benefits of cable bracing system over this rigid system, as these wires are especially designed for like for this application, and these wires are pre-stretched, which we used to deal with, and then this resists loads in tension 100% of the time. And there is the main important part is the KL over R limitations. It has no limitation in this case. Whatever the drop you have from the ceiling of your service, it could be used, and there is no any kind of bending moment effect as we are facing in the rigid bracing system. And members on both sides of component guarantee structural safety, ease of installation, which is the most another most important benefit. There are few common terms in bracing, which includes lateral bracing, which is also called transverse bracing. As this lateral means it's like refers to the direction perpendicular to the axis of the pipe. We have longitudinal sway brace. This longitudinal sway brace is basically the those braces which are acting along to the axis of the pipe. Then we have four-way sway brace, which is wherever you have required to control the system by all four directions, then four-way brace shall be applicable. Lateral sway, when we talk about transverse bracing or lateral bracing, it has its own like criteria how to install these supports, and different standards recommends for different, as we are, if we are dealing mainly with firefighting pipes, then all recommendation shall be applied according to the NFP 13. And if you are dealing with other services, then based on different standards we can recommend and for this design and calculation and recommendations. So for transverse bracing, we have criteria for it will be applied after every 12 meters, which is the maximum distance could be considered. But if it is possible, or if we have different conditions to put these supports within this range, we can go for less as well, which is totally fine. And every feed and cross main line needs to be braced, and branches we have certain criteria for more than 2.5 inch, and it should be braced from the first brace should be 1.8 meter from the end of the pipe. Then we have longitudinal bracing. Longitudinal bracing having its own criteria to put the supports. When we talk about longitudinal bracing, it has requirement, it has criteria for 24.4 meter, the maximum distance or span between the supports. It could be less based on the, depends on the condition. As we talk about the wires, we have this pre-stretch aircraft cables, which is UL listed and ICC ES listed and complying with NFP 13. And this all of our system, obviously it is complying IBC and UBC building codes. And we have this all design, our all design and products are according to all these standards like ASC 19, ASC 716 and NFP 13 as well. We have color coded wires from gold to green, and these color codes represents the different, to identify the different load carrying capacity or the capacity of the wires. Then we have this crimping sleeves, which is used to lock the wires after brace, after completion of the brace, to lock the wires. And these are also are UL listed and ICC ES listed according to the NFP certification. Zinc coated steel bodies with excellent corrosion protection properties. And we have other accessories like brackets. If you have a requirement to fix to the, obviously you will have to fix to the structure, but if you have any requirement which is related with the clamp, and in case of direct trapping on the pipe, no retrofit bracket shall be used. The slot one which you can see, it's the retrofit bracket. Another one is a universal bracket. Universal shall be fixed to the ceiling, and retrofit brackets shall be fixed to the clamps. Then we have snubbing devices, which is used to control this uplift force movement of the floor mounted equipment, and applicable for also for those equipments where you don't have vibration isolator, because if you have vibration isolator, then obviously this should be considered according to the seismic requirement as well. So instead of normal vibration isolator, anti-seismic vibration isolator shall be recommended. In case you don't have isolators and you have seismic requirement of the component, then seismic snubbers shall be applicable. And this main advantage of these snubbers, it can control motion from all directions. Then we have channels. If you have any requirements for the, if you are dealing in any kind of rigid bracing system, we have full capacity of channels along with the connectors and all accessories. Then we have chemical anchors, mechanical anchors, which is seismic certified, having seismic category C1 and C2 as well. Risers mainly, when we talk about riser, there are a lot of standards, but it's mainly depends on the actual application on the site. And in case of any kind of support which installed already, and it is well enough to sustain the seismic forces, then there should not be any requirement for any kind of additional brace, because there are a lot of things. You have space constraints, you have enough support with the isolators of this expansion and this contraction, and after that sometimes we used to see there are requirements for the bracing. So if it is not applicable, then this mainly the riser designs are depends on the normal support capacity. If it is enough, then no need for additional brace. If there is an additional brace, then there will be certain requirement to follow the span, like transverse and longitudinal risers having its own criteria to have a span maximum 7.6 meter. And then last point is where bracing shall not be required where risers penetrate immediate floors. Obviously, if risers intermediate floor is passing through intermediate floors, then no, in multi-story building, then no need for additional brace for the risers. Here we have design methodology, where we will discuss about how to approach, how to design any system. And this approach must, in general, we all need to understand to design any kind of seismic or to apply any kind of seismic treatment. In design methodology, we have certain parameters which we need to understand, which are more important while when we are designing non-structural component seismic treatment. We must need to know few important parameters like project soil profile type and site class, which could be easily available in the soil investigation or soil reports of the project. Before this, it is mainly related with the structure or mainly related with the agencies who are doing this all soil profile calculation, designing, or what you call it, this survey. Then after that survey, they must have this report, and based on that report, it could easily decide which project soil profile type it is and site class it is. Then we have component importance factor, which could identify while we are dealing with seismic. This importance factor is very, it's like everything in seismic, because most of the system are designed based on the importance factor, and we will discuss this importance factor in detail. Then we have building occupancy category, as I show you in my earlier slides. It's building occupancy category. We have 4 categories according to IBC, and these categories are categorized from category 1 to category 4 based on the high risk. The more number that there will be, the more risk. Then seismic design category. After all this computation, we have seismic design categories to finally to check the system, and this design category would be able to allow us or to do us design based on the different standard, whether it's required for life safety services or non-life safety services. It depends on the design category value, design category coefficient. And while we are dealing with seismic, we have this few important references, few important books, standards, whatever we call it. Then it's this building codes, which is in building codes we have IBC, we have UBC, and also while we are dealing with fire, when we are dealing with non-structural component, then ASCE recommendation. This prevails for all kind of non-structural recommendations. And if we are dealing with firefighting pipes, then obviously an FPA 13 would be recommended or would be applicable for all firefighting pipe systems. And then if we are dealing with any kind of, sometimes you have rigid system bracing, then seismic restraint manuals from SMACNA can be applicable. Practical guide to seismic restraint, which is a summary of all from all different standards, this from ASHRAE. And then we have for electrical, we have different design references, and these all can be useful. These are design references or books or standards can be useful to design any seismic system. As I told you earlier, like this before this slide, then we have soil parameter, soil profile type, and site class. So based on IBC, we have different based on different site class, and which is representing by A, B, C, D, E, and F. And most of the soil classes we have in our region is C. And this could be easily if we are totally MEP service provider, or if we are dealing only with MEP services, then it could be easily get from the project consultant and from this survey company who did this, who used to do this survey for the soil, and in their reports it's easily available, mentioned which soil profile type and class it is. Then importance factor, as I mentioned, importance factor is importance factor, and it is also very important to categorize any seismic system. So importance factor is basically categorized in two categories, 1.5 and 1. If we are dealing with any kind of life safety services, if we have firefighting pipes, smoke management ducts, if we have any service which is related with the life safety purpose, that system comes under IP 1.5. And for all components which is related with non-life safety services like chilled water pipes, plumbing, drainage, this all kind of this is IP 1.0, and this is not serving any life safety. But here is one more important point, is because this is it is categorized by 1.5 and 1.0, but sometimes we have some system which is more close with the life safety services, and if this system having any effect, so this will automatically affect your life safety system. Let's say you have two parallel pipes, one is firefighting, other one is chilled water pipes, and chilled water pipes unfortunately is more bigger in size, which is going along with the firefighting pipe. So if you have any movement in chilled water pipe, that could affect your firefighting system. So this chilled water pipe comes under 1.5. But this all needs to be assessed carefully, because we cannot put this blindly. We need to assess each service, each floor, each service, each area to categorize this system. So this is the overall this explanation for component importance factor. Hopefully you all got this very well. Then we have occupancy category. It is repeating again. This is the same occupancy categories as I show you in my earlier slides during the start of this presentation, and it is categorized by 1, 3, and 4. And where we have low risk buildings 1 and 2, like schools, assembly halls, other buildings having occupant load, or what you call it, the number of residents is more than 5,000, it comes under category 3. Then we have seismic design category. It's based on occupancy category, and this seismic design category, we like based on occupancy category and SDS value, we can easily locate by single line interpolation method which seismic design category it is, and based on those the recommendation from ASCE for that design category, we would be able to decide which service needs to be seismically restrained. Here we have bracing requirement based on importance factor and SDS, which is IP 1.5, IP 1.0. If we have seismic design category C, then IP 1.0 shall be totally exempted, and only for life safety services shall be required. And then if we have seismic design category D, then in that case both services IP 1.0 and 1.5 having importance factor both needs to be considered for seismic treatment. So up to C, A and B doesn't require any kind of, it's totally exempted from any kind of treatment for seismic. But design category C, it's basically for those equipment which are mainly serving for life safety. And D, E, and F is for everything. If you have design category D, E, and F, then every system needs to be seismically restrained. Based on sizes, but this sizes having we reach somehow to create this table to give summary for this size requirement based on IP and 1.0 and 1.5, but this mainly contingent with the load requirement. If we have more loads and all, then it's basically needs to be assessed by the load rating of the pipes and the services. Here we have, according to ASC 705716, we have seismic force. This seismic force needs to be, this is the formula relation to compute any seismic force, and it is FP, design horizontal seismic force. AP is the component amplification factor. and this short period design spectral acceleration and component importance factor IP 1.5. And then we have vertical seismic design force, which is the component must be designed for concurrent vertical load, which is 0.2 SDS and WP. Then after this bracing, after this all bracing for the suspended surfaces, we have overturning force calculation for the equipments. Whenever, and it is recommended by the ASHRAE, if we have some tensile force calculation, then we can use this relation. And if we have compressive forces, then we can use another relation to calculate any kind of overturning force on the equipment. The shear force on the equipment, because of seismic forces defined in ASHRAE as by using this relation. Then we have shear forces as well defined in ASHRAE, which is recommended from ASHRAE. So which needs to be done for the anchors and the devices for all kind of shear forces to check. It's never to check to do these calculations and check the snubber models whether which one is applicable under this load based on the snubber load rating. After all, we have some by using this design methodology, seismic restraint system, and then first initially we discussed the introduction, then we had importance of this seismic events, then we have how does these seismic forces affect on MEP system, then we have seismic restraints, then we have design methodology, which how to calculate or how to do any kind of general idea or general like concept, how to do this design for any kind of seismic requirement. Then eventually we have application examples, and this example will show you some examples how we used to do the calculation and how we contribute in this all system. Here we have one project of school, and this having some giving you an example of firefighting pipes 100 mm, and this obviously this school comes in occupancy category 3, as we mentioned, schools, assembly halls. Then we have seismic design parameters, and we need to calculate based on soil profile type. We have SS and S1, and obviously from this ASHRAE, or you can check in IVC chapter 16, and you will get this all seismic soil parameters based on SS. You can get site coefficient FA, and after the computation of SS and FA, you can easily calculate SMS, which is FA into SS. Then SDS having a relation is 2/3 of SMS, and it's equal to, and in this case it is equal to 0.44 G. So seismic site coefficient FA, as I mentioned, can be located by single line interpolation method in this table, which is from ASHRAE also, which is available in IBC chapter 16 as well. So based on SDS and occupancy category, we would be able to calculate this seismic design category, as occupancy category is 3 and value of SDS is 0.44, so it comes under seismic design category C. And based on seismic design category C, your all services which having the IP 1.5 shall be required for seismic restraint system. Here we have this all computation formats, how we used to do the calculations for to calculate the seismic force. Here you can see this type in this below chart. We have type of restraints, transverse longitudinal pipe sizes. Based on pipe sizes, we have certain weight kilogram per meter, and then we are having some factor of safety. After that, we have some G. G is basically the seismic force factor, and it will be multiplied by the total load and gives you the seismic force. And based on seismic force, we used to recommend our products which having the certain load carrying capacity and in different ranges, and it will show you at the end cable utilization, as we are using here cable kits. So cable utilization at the ends of our formats, and then we have tension and shear forces for anchors, and then anchor description. This is our, like as we are doing only, not doing only calculation, we are doing markup drawings to create the support location and providing you each support typical details, how does it look like, so contractors can easily follow our drawings and do their installation and to support, to locate the supports location. Here we have some photos of our cable bracing system, which is already installed in the projects. And this is longitudinal kind of transverse kind of bracing by using cable braces. And this is our rigid system, where we have steel structures and where rigid system will be applicable. And we have this pictures. So from my side, thank you so much for this, all of your presence today. Now we will discuss about we will answer your questions, and then now let me open this question bar to discuss this all. Yeah, so I want to know if anyone having questions, so I can answer you. I'm waiting for your all of your questions. If you have any concern, then you can ask these questions related with design, related with products, so I can answer you immediately. Yeah, for we do apologize for this all happening in the webcam and this presentation. Now your question is, Mr. Anit Kumar, is this cable bracing system designed using any specific software? Actually, this is all designed based on different standards. So we have software, but this all calculation based on all IBC and ASCE recommendations and the relations which are recommending for the seismic calculation. Yeah. So from Mohammed Parvez Alam, your question is about most of the time data are not available. In that case, is there any thumb rule to calculate seismic force? Yes, there are. If you don't have enough data, and then in this case, design category D needs to be considered, and as per the ASHRAE. But if you have some kind of clue, at least what type soil profile type it is, then or based on region, we can recommend you. Like it depends on the on your region of the project, and we can recommend you this forces could be applied. This seismic force factor shall be applied for your system. Yeah, from Mr. Umar, we have, yes, we have. Are there any approval certificate about seismic force? Yes, we have approvals. We are having UL listed products under the compliance of NFP 13, which we are using for seismic application. Then Mr. Halil Aras, how we can decide which force should we use from wind and seismic? Actually, for wind and seismic, both having different recommendation and different way of calculating seismic forces, as we are mainly discussing here seismic. So I already show you in my presentation the seismic force formula, which is from IBC and ASCE. And and for wind also available in ASHRAE recommendation for seismic restraints, and wind load calculation can be done by using those relation, which having the same kind of formulas available in references. So Mr. Vikas, your question is, what is the most effective way to marketing your product range with consultants? Actually, the most effective way is to is to deal with the disasters, because if you are having project and this project you need to understand how does this project is important for you as an application point of view. So obviously consultant having this concern about whenever we are dealing with seismic, they have more concern about the seismic to save the system. So this is the like most effective way is the risk of the services. To control that risk, you must need to propose this seismic restraint system from us. Yes, sure. We will share with you this presentation, Mr. Omar. As we do apologize, we in the earlier of the presentation you were not able to see this presentation because of the webcam issue. So, Vikas, this your question, they are mostly talking about cost. For this is basically it's based on cost. And what is your question? Can you please repeat your question? So I will answer you specifically, because this mentioned they are mostly talking about cost, because it's okay. Your point is most effective way to marketing. Yes. Okay. So in this case, if there is some kind of additional cost is bearing, then we need to explain them, like how we are dealing with this risk. If we are not spending bit of money on this by saving this system, then all could be collapsed if we have any risk or any kind of earthquake. So in that case, and best design effective solution, which is more economical and more logical in design aspect, that could be proposed to the consultant for this marketing for these products. What base, Mr. Akram Nawaz, what basic this should ask from MEP engineer for quoting purpose? This basically we need the, if you have project soil reports, most of the MEP contractor doesn't have, and then based on like project specification is the most important, and based on soil profile and project specification and project drawings, if you provide us, then we would be totally able to give you our solution. In Riyadh, mainly it's seismic design category is C shall be applied, but it depends on the reports and it depends on the soil investigation. Mainly it's related with the soil, but when we talk about the regional point of view, in Riyadh it could come under seismic design category C, and soil profile type shall be C. Yes, Vikas, I got your point, because if you are dealing with wires, and wire will be, because we have different aspects, we have different ways to control this effect and this cost impact. The first one is the most effective design, where you have the most effective design to in more economical way to control the system. And the second thing is the product selection. If we are using that type of like cable bracing system, which is more cheaper than the other types, then it would be more cost effective for your case. Anyone else wants to ask the questions? Mr. Akhil Kumar, this RU support system all fire rated and UL certified. Yes, our all support system wire rope bracing system are UL certified and under the compliance of NFPA 13 as well. Yes. Anyone else having more questions? Yeah, sure, Mr. Akhil. We will share the presentation. Okay, fine. Okay, nice to have a session with you, all of you. Thank you so much for your presence and time. And and we will be keep in touch. If you have any queries, if we miss out any answer of your question, then you can directly contact us on Hira Wallabin Academy, and then whatever the details you require, we will share it with you. as soon as possible. Thank you so much. Thank you so much all for your time. Have a great day. Bye.